Okay, couple things. Dismiss recording. There you go. First of all, 4.8 quiz is open again because I had the wrong time or the computer picked the wrong time. So you have until this evening to complete it. Make sure you get this done. And 5.1 is open right now as well, and 5.2 just opened literally probably a second ago or a minute ago. And depending on how far we're getting today, maybe I open 5.3 as well. So a couple people asked me what can I do to improve my grades and this and the other. So I can only stress, and people who are not here right now, I hope you listen to this later, do your quizzes. Your quizzes are worth 10% of your overall grade. I will not open the quizzes up again. So you have to do your quizzes, and there's still a bunch of quizzes that will come down during the last 4 weeks. So I would highly, highly recommend to start turning in quizzes if you haven't done so already. And you know that I will drop the 3 lowest quiz grades. So that's one way to improve your grades. Another way, of course, is homework. Now, these are all easy grades, and it makes me mad, sometimes more than students. Like, for example, if you have an average of a 65, and 10% is your homework, and you haven't turned in any homework. So that would mean you have to take the course over again. Instead of doing your homework, which is not that many problems, and get the 10%, and now you have a 75, and you move on to your next math course. When is the final exam, Tony? And that is a good question. The final exam is usually on the last day of regular class, but the last day is a Wednesday. It probably will be on a Monday, but I'll let you know for sure. And you know how bad I am with dates. I know the last day is the 11th. So it either is the 11th, that last day, or the 9th. I'm going to have to look at the calendar and consult with other faculty, but I will let you know either the 9th or the 11th. And I also will let you know of the modality of the final exam, since we are flex class, if it will be in person or if it will be online. I'll let you know that as well. So where was I going? Quizzes, homework, and discussions. Now, these are 30% of your overall grade that you have control over. And those are points to be accumulated that are not, I want to say, as difficult. So I, again, highly recommend, if you haven't started yet, and that's more for people who are not here. Hello, do you listen to me? I hope you're watching the video, that you turn in homework, that you complete the quizzes, and you do the discussion. The only opportunity I say is to get some more points is, as I mentioned earlier, I will open up all the discussions again. So that I will do. So therefore you have a chance to redeem your discussion grade. Mark says, when is the next math talk? That will be April 12th on Tuesday. Oh, that's coming up. I better get going. That will be the 12th. And yes, I know what the topic will be on because I'm the one who will be giving the math talk. And that will be on the TV show Friends. And statistically analyzing through math on who was the best friend in that show. I cannot say that I have watched Friends on a regular basis, but of course I know about Friends. That show hasn't been on in quite some time, but I found a very interesting article, and I thought I wanted to share this with students on how we can use statistics and analyze TV shows. Actually, I want to say, because whenever I turn on my TV at home, and that's just the way it's programmed, I guess. It always starts with channel 12, and I think that's TBS, especially in the afternoon, and Friends is on. So I want to say, even so Friends hasn't been on in 10 years, I probably watch it more now than I did when it was on, because the TV always automatically comes on when Friends is on. It's a weird thing. Anyway, Mark, I want to say it's from 11 to 12. I'm pretty sure we said 11 to 12. Yeah, 11 to 12. Or was it 10 to 11? You know me and times and dates. I don't want to, I will post it after class, and then you can see. It's either from 11 to 12 or 10 to 11. I want to say 11 to 12. Okay, what else? So math talk, if you can attend it, I want to give it some extra credits on your next test. So you can receive, I don't know how many points. Let me think about this over the weekend, but you can receive some extra points on your test. Which brings me to my next point. Test. Oh yeah, there I said it. Test. Okay, so one way to make up some points is discussion. The end of the semester, I will open them up again, make sure you complete the quizzes, the homework. And I looked and see how many people turned in homework for the last test. And I have to say, it's never a lot of students. And unfortunately, it shows. You guys, you need to do homework. If you don't understand something, you need to come and see me or go to the ASC, but you got to get it going. I want you to get out of this class, but I need your work, and I'm the last person not to try to help you as much as I can. So having said that, your tests are graded, are just about done. I think there's one more. After class, I will, like I mentioned on Wednesday, I will scan them to you individually, and you can turn in test corrections. So there's another way to get some extra points back on your test. These are optional. I can only highly recommend telling you to do these test corrections, but in the end, it's really up to you. And if you say, oh, I got the problem wrong because I don't know how to do it, then you have ways to get in touch with me. And especially on Sunday, I have virtual office hour. That would be a good time to ask me questions or just email me. And sometimes I do virtual office hours outside of the regularly scheduled office hours. Tony Ann is saying something? No, you didn't. How was your birthday? Oh, you had a party. You didn't invite us, right? I'm just kidding. Okay, we got to get going. So you guys, you know what to do. I am here to help you, but I cannot do it for you. So, like I said, I'm trying to find points everywhere I can, but you got to do it. And so that's where we are. Of course, the final exam will replace your lowest chapter test grade as well. Any comments, questions? If you want to talk to me in private, just email me, call me, call the Google phone number, text me. Usually a lot of students use it, but I don't know what's going on this semester. Okay, some people look like they're typing something, but I don't know if you're actually typing. I'm going to go into those areas now and get going with, is every number infinite if you keep breaking it down using percentages of topic? Is every number infinite? If you keep breaking the number down, yes, then it is. Using percentages. Either way, percentages or not percentages, if you keep breaking them down into something smaller, larger, there are infinitely many possibilities. Yes, Mark. Oh, I'm sitting in the dark. Okay. Story of my life. There you go. Okay, let's get going. Factoring. So guys, if factoring is something, I don't like it, I don't want to do it, and I was just talking to a student the other day, yes, we're all human, and I'm sometimes the same way. If there are things that you don't like to do, not you as, or one does not like to do, we wait until the last possible moment to get them done, right? Right, I've been there. I've been to school all my life, college, universities. There are classes, and yes, they included math classes as well, that I really was dreading. I'm like, oh. But in the end, you know, we gotta get it done. And where is dosary? I'm trying to find dosary. And you cannot wait until the last possible moment. Oh, we have a test today. Now what? I can't find dosary. Here you go. There it is. I talked to the IT people again, and they think the dosary issues with the Teams is a Microsoft update, and they're looking into it. They think that the updates with Microsoft and dosary and Teams, they may be interfering with each other somewhat. And here we are. Give me 1 second. I will share the screen in 1 minute. I was waiting until I should have shared it's totally my fault now. I got to share the screen before I get into dosary. Okay, let's try this again. And also, if this modality as in HyFlex course is not so much for you, come to class. Even on Fridays, I'm here. If you want to see me in person, then do that. And that's also a good way to then follow me to my office and get some more questions answered. Okay, let's recap a little bit. Chapter 5 is all about factoring, and in 5.1 we talked about rational functions, rational expressions, and finding domains, and then we simplified. We're going to continue this a little further today. So I like to, what I do for chapter 5 usually, and then students do it actually pretty good on chapter 5. Once you get the factoring down, is to review every single time we work in chapter 5. So this is a function, I made it up, and we have to evaluate that function at 0. So what is f of 0? Help me out. F of 0. Function notation, we're replacing the x values, every single x value that you see, with 0. I hope you can hear and see me, and oh, that was fast. Oh, I haven't even finished yet. Okay, so I'm going to write 0 squared plus 2 times 0 minus 5 over 0 plus 3, and the answer indeed is negative 5/3. So here you go. Okay. Something else we talked about on Wednesday was finding the domain. So what is the domain of this particular rational function? How do we find the domain? We have to set the denominator, which in this case is x plus 3, equal to 0. And then we solve for x, which would be x equals -3. And that is the RV, the restricted value. No, it's not -5/3, Mark. We have to look in the denominator. The 5/3, the -5/3 is really the y-intercept. When x is 0, what is y? So we found our restricted value. So at -3, this function is not defined. Elijah said it correctly. Then your domain is -infinity to -3, union -3 to infinity. Done, you are. Tony Ann, not 5/3. Chloe has it as well. It's the 5/3 was just for me to get you to practice function notation. But the 5/3, like I said, is really the y-intercept. To find the domain, you strictly have to look at the denominator. Which brings me to my next question. I'm giving you a domain, and I would like from you an example of a rational function that has this domain of -infinity, -1, and -1 to infinity. There should be several different answers. I just want an example. And the example is Valentina says, okay, the easiest one, Mark had to really. The easiest one would be 1/x plus 1. Right. Here you go. Now Mark is giving us an example that is x squared plus 5x minus 2/x plus 1. Yes, that is also a good example here. So either one, if you are given a domain, you just come up with an example that has this domain, and if the RV, the restricted value, let me write it down here, x equals -1, then the denominator has to have a +1 here. So it's always the opposite sign. Okay, what else did we do? We simplified. We started simplifying, and you saw why it was so important to know how to factor. Because in order for us to factor, I'm going to say it again, oh, 6 goes into 12 2 times. No, 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 you are not allowed to do that because there's a plus in between. So we have to factor first. How do we factor the numerator? GCF, Chloe says, is 2, but not just 2. Elijah says 2x. Right. The GCF is 2x. So first of all, we are dividing out the 2x, which leaves us with x squared plus 6x plus 8. All over 6x plus 24. Let me just one step at a time. Now you have to look and see, can you factor the numerator, whatever's in the parentheses, this trinomial further? And guess what? It can be factored further. How? Which two numbers multiply to 8 and add to 6? 4 and 2, you got it, x plus 4, x plus 2. How do we factor the denominator? GCF is a 6, and you're left with x plus 4. So again, first you need to factor. We need to get it into multiplication of factors. Now we can reduce whatever they have in common. X plus 4 over x plus 4, that reduces to 1. Can I reduce anything else, or am I done, or what else is going on here? Done. Mark says done. Question mark. Anybody else? Any comments on, is it done? Yes or no? Elijah says reduce the 2. You are absolutely correct. This says 2 times x 6 times. So we are allowed to reduce the 2 goes into 2 once and into 6 3 times. So yes, you must do that. And now our answer is x times x plus 2 all over 3. That we have to reduce the 2 and the 6. Any questions here? Now, another advice I would want to give you is to always do your homework as we are completing the section. I felt there's something to be done that too. Yes, you needed to do something. So as we are completing the section, I highly recommend you doing your homework. That way you can ask me questions. Let's see. Now, this was an example where people were just reducing, aimlessly reducing everything. That's wrong. You're not allowed to do that. You have to factor first. But I wanted to do one more problem out of the book, and that was actually a problem where you kind of didn't have to factor. Number 32 on page 388 is 48 A, B, 3, C, 2, all over 6, let me see, I can't see that, A, 7, B, and C, 0. This is a problem really where you A, have to know how to reduce fractions, and B, need to know how you use your rules for exponents. So let's take a look at that. Now we know that 6 goes into 6 once and into 48 8 times. So we do have an 8 there. That is for sure. How about the A and the A7? What's going on here? We have 1 A on top and 7 A's on the bottom. How many A's do we have left, and where do they go? Anybody? Anybody wants to try? A6, that is correct, and that A6 would be in the denominator. Yes, because A, let me just, 1, 2, 3, 4, 5, 6. So 1A reduces with 1A, and you see that we still have 6A to the 6th power in the denominator. How about the B's? The rules for exponent is that you are subtracting them when you are dividing. So b 3 minus 1 is 2. And we have 2 minus 0 is still 2. So C2 on top. That would be the answer in reduced form. Are there any fractions? Yeah, that too. Any questions? Let's see, this is, now, just as one more time, 6 plus x over 2 plus x cannot be reduced. Why not? Because there's a plus. This is one factor. You are not allowed to reduce it. Let's simplify this one here, and then I think we're going to go to 5.2. Simplifying means you have to factor first. 25 minus x squared. How do you factor that? (25 minus x squared). That is a difference of two squares. That factors into 5 minus x and 5 plus x. Yes. Now let's take a look at the denominator. This is a trinomial. Leading coefficient 1. Need an x here, an x there. We're looking for two numbers that multiply to 25, but at the same time add to 10. Negative 10. And Elijah, that would be negative 5, negative 5. Yes. Okay. Now, we talked about this on Wednesday. When we have addition, x plus 5 over 5 plus x, addition is commutative, so we can just reduce, that would be 1. Subtraction is not commutative, but how did this reduce? 5 minus x over x minus 5, the order is changed. If it was x minus 5 over x minus 5, if it was the same order, would be positive 1 as well. But since the order is reversed, what did we say? This reduces to, you are correct, negative 1. So what I said on Wednesday was when you have subtraction, put your negative 1 in the numerator like so. Reduce it to negative 1, and that's really all we can do. So we have a negative 1 times 5 plus x over x minus 5. There's nothing else that can be done. If you want to distribute the negative 1 and write negative 5 minus x, you can do that as well, but you don't have to. So these were some examples from 5.1. In 5.2, we're now multiplying and dividing rational expressions. But we're basically doing the same. We have to factor and then we reduce. Let me remind you of how to multiply fractions. Let me make something up. 3/5 times 2/7. How do we multiply fractions? Well, we multiply numerator times numerator, which is a 6. Denominator times denominator. Oh, 5 and 7. That brings me to a question on the test. And I know you guys all know this. You had to factor x squared plus 2x minus 35. And it was like, I don't know what was going on. You had to find two factors that multiply to negative 35 and add to 2. I saw all kinds of factors there. The ones that I did want to see, I didn't see that much. Positive 7 and 5. 5 and 7 is the only two numbers that multiply to 35. Just the 35 here made me think about it again. So here it is. And that should be, 1 should be a negative 5. Here you go. 7 minus 5 is 2. 7 times a negative 5 is a negative 35. I can sit in the dark. You don't really need to see me. I don't want to get up now. Okay. What about if you have, for example, 3/5 times 10 over 24. Now with the first example, I need to have a light on, I can't sit in the dark. With the first example, we couldn't reduce. But here, we can actually go ahead and we can reduce diagonally, or we can reduce up and down. 5 goes into 10 2 times, and 3 goes into 24, what? 8 times. And then, oh, look at this. So now we've reduced diagonally. I can also reduce up and down. That's a 1, and that is a 4. So the answer here would be 1 times 1 is 1 over 4. What I'm not allowed to reduce is going side to side. In other words, numerator against numerator. That is not allowed. But you can reduce diagonally, or you can reduce up and down. That is allowed. Okay, so here are the steps that are listed on page 390 of how to multiply rational expressions. And the first step, again, is just like we did in 5.1. You have to factor, if you can, the numerator and denominator. You got to factor completely. Here's a misprint, I think. That probably should be a 2. There you go. Factor numerator and denominator, and then we're going to reduce. Actually, I'm going to put this as step 2 and this at step 3. Reduce common factors either to 1 if they are the same, or -1 if we have subtraction. And then we're going to multiply numerator and denominator and see what's left over. It's pretty much the same as we did in 5.1. So here's our problem. Let's factor 3y minus 6. 3y minus 6 factors into 3 times y minus 2. Plain, simple GCF problem. And we're going to leave the 6y here because they cannot be factored right now. Maybe we need it later. The y squared plus 3y plus 2 factors into y plus 2 and y plus 1. Yes. 2 times 1 is 2, and 2 plus 1 is 3. And the y squared minus 4 is the difference of squares, and that factors into y minus 2 and y plus 2. Guys, are you with me? So the first step is to factor it all. Yeah, okay. I see you. Yes. Okay. So we're factoring everything we can. Now we're going to reduce common terms. We have a y minus 2 and a y minus 2. That's 1. We have a y plus 2 and a y plus 2. That's also 1. Now don't forget we have a 3 that goes into 6 2 times. And I do believe that's all we have left. We cannot factor any further. So in the numerator, we have a bunch of 1s, and then we have a y plus 1. And in the denominator, we just have a 2y. The 2 here and the y, and the other 2 factors reduced. And that's our answer. There's nothing else we can do. How do you like that? I like it. Okay, you try one. Well, let's talk about division first, because division is very similar, and then you guys try one. So for dividing fraction, okay, Tony, I like it. Yeah. If we're dividing fractions, you multiply by the reciprocal. Now, the first fraction that you see, that does not change. That's an A here somewhere. So we have 15 over 14. This division turns into multiplication. Multiplication of the reciprocal. What is the reciprocal of 10 over 49? Well, we flip, and this becomes what? 49 over 10. Not negative, just 49 over 10. You're thinking about perpendicular lines. This is not that. We're just getting the reciprocal, which is 49 over 10. And then we would multiply and we would see, okay, diagonally, is there anything I can reduce? 7 goes into 14 twice and into 49 7 times. 5 goes into 15 3 times and into 10 twice, and that's all she spoke for. The answer would be 3 times 7, 21 over 4. So multiply by the reciprocal, and then see what's left, factor, and then we go from there. Okay. I'm going to help you just to rewrite it. This is number 28 in the book, so you can clearly see it's a division problem. And this division problem, a over a minus 10, 10, needs to be changed into the multiplication of the reciprocal, which is a squared minus 100 over a3 plus 6a squared minus 40a. Here you go. You do the rest. I'm going to give you a minute. Now, again, you have to factor all that are possible to factor. And then we reduce. Now, the only thing I'm going to do, a over a minus 10 cannot be factored further. Now you do the rest. Where are the rest of the students today? Hello, missing students. How are you doing? Are you out for lunch or just doing something else? You know, it's Friday. How would you factor the numerator? A squared minus 100. Difference of squares, you are correct. Difference of squares, so mark 2 and 50 would not be squares. When we say difference of squares, that means really that we have to find the same number that multiplies to 100. So 2 and 50 are not squares. Yes, Jordan. So the 100 would be 10 times 10. You're basically taking the square root. Valentina, I can see it. So it would be a minus 10 and a plus 10. And now we got to factor this trinomial. This trinomial is a two-step of factoring problem because it has a GCF of 2. You got to factor out a 2, which leaves you with a squared plus 6a minus 40, first of all. So that a is definitely a factor. And now you have to come up with two numbers, multiply, give you negative 40, but at the same time add to 6. And Elijah thinks that's 10 times negative 4. That's negative 40, and 10 minus 4 is 6. I think so too. A plus 10 and a minus 4. Okay, now we are ready to reduce. We can reduce an a minus 10 with an a minus 10. We can reduce an a plus 10 with an a plus 10. Those are pretty obvious. And what else can I reduce? Chloe says a times a minus 4. Is that your answer or what you're going with? Can I reduce something else? The obvious ones we just reduced. Could you reduce the A marks questioning? So answer mark. Somebody answer mark. My answer, but I changed my mind. Okay, Chloe, I would change my mind too. Yes, to answer Mark's question, because of multiplication, you are allowed to reduce the A's, and that's all we have. So now what do we have left? And unfortunately, Chloe, a lot of students write as an answer a minus 4, and that is incorrect. That's why, Jordan, you are correct. That's why it's so important to write the ones down. Because if you don't do that, you may just, oh, it's a minus 4, it's just left. But we have ones in the numerator, so it's 1 over a minus 4. Be careful about that. That is a common mistake. That is why you always will see me writing the ones. Oh, she's reducing. Why is she putting the ones down? They cancel each other out, and then they are gone. They are not gone. They are 1. Okay, let's take a look at 46. I have no idea what that is. Oh, 46 is a long one. Ooh. 46 is x squared minus 4y squared over x plus 2y divided by x plus 2y times 2y over x minus 2y. So, okay, here we have 3 expressions, and one is a division. So, which means, and another tip I do all the time, if you don't see a denominator, it's over 1. Keep that in mind. Because now, if we change this division into multiplication of the reciprocal would be 1 over x plus 2y. Guys, are you with me? I hope so. Now the last multiplication is just, there's nothing I can do to factor it, so I'm gonna copy it down. There's nothing we can do here. Thank you, Rodney. The first of those expressions need to be factored, and I told you that on Wednesday. So if you want to review some factoring, I highly recommend you reviewing differences of squares and trinomials. The difference of squares is what we got here, x squared minus 4y squared. How does it factor? The denominator over here cannot be factored. So there's really only one factoring going on in this problem. It looks like a lot, but there's not much going on. X squared minus 4y squared. Students, factored. X minus 2y and x plus 2y. Remember how I factored the difference of two squares? I wrote it out the long way, 2y, 2y. Then I took the 2 in the middle, and then I took the other 2. Okay, again, this problem looks like a lot, but you really only had to factor once. You had to remember that you changed it to the reciprocal. What can we reduce here? Let's see, we have an x plus 2y with an x plus 2y. I just went up and down. Which one you eventually reduce doesn't matter. And then we have an x minus 2y and an x minus 2y. And guess what? That's all she spoke for. So what we have in the numerator is a 2y, and in the denominator we have an x plus 2y. And don't even think about it. Oh, look, we have 2y's. Okay. Oh, yeah. No, you cannot. That is it. How does that make you feel? I had an instructor once who asked me every 5 minutes, how does that make you feel? I didn't like it after 5 minutes. I want to do one more, but that's basically 5.2. Let's do one more and then we go into 5.3. How about you want to do a real long one? Ha ha ha. A real long one like number 33. 33 is about the most fast. 33 looks pretty intense. We have a to the third plus a squared plus 1 over a cubed plus a squared plus ab squared plus b squared. Now there's a division, so in order to save some time, I'm going to flip it and multiply. 2a squared plus 2ab plus ab squared plus b to the third. I don't know why. Plus a squared b plus b. Here you go. That looks intimidating, but in the end, every single one has 4 terms. So here we have to, yes, Mark, here we have to factor by grouping. All 4 of them. Yes, that is a little work. And I'm going to do a little sidebar because, so I have enough room. A little sidebar down here. A cubed plus a squared plus 1. That's not something even I have to do grouping here. I mean, I kind of could factor it, but let's group it. The first 2 have an a in common, and you're left with a squared plus 1. The second 2 have nothing in common, so you got to factor out an a, and you're left with a squared plus 1. So the first numerator factored is a squared plus 1. Remember, we take the common factors now, and then on the other side we have a plus 1. Now we're going to go to the denominator, a cubed plus a squared plus ab squared plus b squared. What do they have, the first 2 have in common? Why do I factor? You factor. What do the first 2 have in common? A cubed plus a squared, they do have an a squared and a plus 1. What does the second group have in common? Oh, the computer died? Did it come back to life? Cool. B squared and a plus 1. Okay, so a plus 1 goes here, and a squared plus b squared, and that is a sum of two squares that I cannot factor. Okay. Let me erase that and go to the other two. Now, if you watch the video, of course, you can stop it. So you make sure. I would do this again, and then you can check yourself, stop the video, do it again, and check and see if you got it right. First two have what in common? 2a, and we are left with an a plus b. And the second pair have a b squared in common, and of course we have to be left with a plus b. If this is not the same, guys, you are wrong. Okay, so that's a plus b and 2a plus b squared. This is some major factoring going on. Doesn't that make you feel good? You feel like you accomplished something. Yeah, it's fun. Yeah. Oh, I should not have put this here. I should put it there. So these first two, a cubed plus a, there's an a in common with an a squared plus 1. And on the other side, we have a b, and we have an a squared plus 1. A squared plus 1 times a plus b. Okay, now let's get to work. I hope there's stuff we can reduce. What can we reduce? A squared plus 1, a squared plus 1. A plus 1, a plus 1. A plus b, a plus b. I feel like I need lots of practice. Chloe, you took the words out of my mouth. Factoring. Practice, practice, practice. You must do this every day. It's got to come in your sleep. If I call you at 2 a.m. in the morning and I ask you how to factor a cubed plus a squared plus 1, you better be awake. You better be home, and you better be able to factor this for me. 2a plus b squared over a squared plus b squared is our final answer. The factoring is just grouping. It just looks like a lot. Mark enjoyed the problem. Me too. But you have to practice it. And maybe if you guys tell yourself, hey, we need to practice more, instead of listening to me, then I had somebody yesterday, because I'm teaching another 1033, and she told me, and I wish I had guest speakers as students come to the classroom, oh, I did so much better because I did my homework. Yeah, that's what homework is for, to practice, to get better. You cannot, unless you really know what you're doing, expect to be proficient in what I just told you from me talking to you in an hour. You have to practice it. You just must. Is the factor, Elijah, what? 2a plus b squared. 2a plus b squared is what we have in the numerator, and we still have an a squared plus b squared. And that is a sum of two squares that cannot be factored. So whatever I circled is our answer. There's nothing, absolutely nothing you can do this problem, even if you think there is. That's it. Okay, look at that again. Let's get into 5.3, and that's really something you're gonna like, because, you know, fraction action. Let's see what this is. I don't want to do this again. We just did that. Here you go. 5.3. Addition and subtraction of rational expressions. But before we do that, we gotta review fractions are our friends. There's A, like denominators, and B, we're going to look at unlike denominators. We may not have time for unlike denominators today, but definitely if you add two fractions, you can only add fractions that have the same denominator. So the way you do that, if they have like denominators, meaning being the same, you keep the denominator the same. So in this case, 2/5 plus 7/5, you keep the denominator the same, which is a 5, and you add or subtract the numerator. And then again, you have to simplify, reduce if possible. And you know what simplifying in chapter 5 means. Factor first. It's all about factoring. So 2 plus 7 is 9. There's nothing we can reduce here. We're done. The next problem, again, we have like denominator. So 15 minus 3 is what? 12 over 4. Now 12 over 4 can be reduced, and that would be 3 over 1 or just 3. Because really what we did is we factored the 12 into 3 times 4, and we have left a 3. Now if you have just variables, well, you still have a q in the denominator. That's still the same, and the numerator would be p plus r now. And if we could factor here, we would have to factor and see if we can do something with that. So again, like denominators, we keep the denominator the same and we add or subtract. So here are some, let's look at this first problem here, 3 over 5x plus 7 over 5x. Luckily for us, the denominator is 5x, and all we have to work is in the numerator, and 3 plus 7 is what? 10. Can we reduce that? That's actually number 7 in the book on page 403. Can we reduce it? The answer is indeed yes. What can we reduce? Because it's all multiplication. 10 and 5. 5 goes into 5 once and into 10 twice. So we reduce 10 over 5, which is 2, and we're left with 2 over x. And that's it. The next one, number 9, also has the same denominator. So luckily for us, x squared minus 2x minus 3. Write the denominator first, and then just work in the numerator, combine these terms, which is x minus 3. Is everybody with me so far? Speak up. Questions? Now what we need to do is we need to see if we can reduce. Again, which would mean, don't even think, oh, x goes into 3 goes into 3 and we go 1/2 left, something like that. No, we got a factor. X minus 3 cannot be factored. X squared minus 2x minus 3 is x minus 3 and x plus 1. Elijah, you are correct. So I factored the trinomial, and then you reduce by 1, the x minus 3, they are the same, which leaves us with 1 over x plus 1. There is your answer. And that, I think, was also a problem in the book. Oh yeah, it was number 9. I wrote that down. If you just write x plus 1, will it still be right? No. If you just write x plus 1, that is actually over 1, which is totally different than 1 over x plus 1. That will not be right. 1 over x plus 1 and x plus 1 are two totally different things. Well, they are reciprocals of each other. But so that would be wrong. That's why I keep writing the 1, so you know what I'm reducing. You should get used to that as well. Okay, last one, number 12. Now you gotta be careful. The denominator is the same, so x plus 1, we're gonna keep that. Now we got to work in the numerator, and in the numerator we got an issue. What is the issue? That minus here. The 4 minus x stays as is, but now you have to distribute this minus. That gives you a minus 5x, that is, and a plus 6. Be careful. If there's a minus, you have to change the signs. And now we're going to collect like terms. Negative 5x minus x is a negative 6x, and 4 plus 6 is 10. All over 8x plus 1. Now the one thing you would have to do now is you would have to see, can you factor the numerator further? Which we can. We can factor out a negative 2, and that leaves you with 3x minus 5. However, that doesn't help our cause. Our cause is always to reduce further. Nothing can be reduced further here. So you could have actually left with this answer, but you may have not seen this before. So it always is a good idea. If you can factor, go ahead and factor and see if you can reduce something. Sometimes we can't, and sometimes we can. Okay, now real quick, we have a couple minutes left. Of course, you will not see really that many problems that have the same denominator, because that's kind of easy. You don't have to do anything. It's more realistic that you come across problems that do not have the same denominator. And for that, of course, you all know it. You have to find the least common denominator or the least common multiple. The smallest number both of these denominators go into. So we have 1/5 and 1/10. We have unlike denominators. The first step is we have to find the least common denominator, and then we have to write equivalent fractions with the same denominator. What is the least common denominator here? 1/5 and 1/10. Tony Ann, you're thinking of greatest common factor. The factor is 5, but the least common denominator is 10. 10 is the least common denominator that goes into, 5 goes into 10, and so does 10. Now the 1/10 is already done. The only fraction we have to change is the 1/5. And the 1/5 needs a denominator of 10. So what do we do here? We have to do something. We have to multiply numerator and denominator by 2. We're not really changing the value, we're just changing the looks. 2 over 2 is 1. I'm allowed to do that. I'm multiplying by 1. So that makes it 2 over 10. 2 over 10 plus 1/10. Now I have the same denominator, which is 3 over 10, and I'm done. If that is something that has been years or, I can't remember, I'll find least common denominator, you may want to go on YouTube and look this up. Now, I don't want to do this one. I want to go to a problem, and then that's the last thing. Hold on. I just want to show you one, because it's actually easier as you think. Usually students do pretty good because I do explain it, I guess, a little different, hopefully, so it makes sense to everybody. Okay, these are two problems. Number 19, it says, find the least common denominator. Not even work out the problem, but just find the least common denominator. You can see that the denominator is already in factored form. All you need to do, in quotes, is find the missing factor. You compare both denominators and see which factor does the other one have, and that's missing on the left side. Which factor is missing on the right side? So if you compare the left side, which is x minus 4, both have this factor, so we're good. Then the left side has x plus 2. What is the left side missing? Which factor that the right side has? You need to look at missing factors. The missing factors for the left-hand side is x minus 6. So if you were to add that, you would multiply both sides by x minus 6. And how about on the right-hand side? What's missing there? Anybody? What's missing on the right-hand side? And x, there is no x plus 4 mark. Both have an x minus 4, but not an x plus 4. Chloe, x plus 2. X plus 2. And that's it. Now you have both denominators the same. So the LCD and the order of those factors doesn't matter. It's x minus 6 times x minus 4 times x plus 2. And that's where we're going to continue on Monday. But basically the way it works is you look to see which factor is missing that one has but the other one doesn't. And then you multiply numerator and denominator by the missing pieces. And that automatically gives us the least common denominator. So we don't have to actually multiply it out and look and see and don't have any idea. Look for missing terms, and that's all you really need to do. Sometimes they are factored, like this number 19, and other times you have to factor it first. With that note, it's 12:09. Any questions? We'll stop right here. I like this chapter. It's fun, but I can't repeat myself enough. You gotta practice. Ready for tomorrow? Yes, I'm ready. And I will be wearing, guess what? Red. What's tomorrow? Tomorrow is Ferrari racing at the Speedway. And yeah, you can find me. Okay, guys, have a good weekend. If you are at the Speedway, look for the Teacher with the red outfit. I was going to say something else, but I'm not going to. Okay. I don't have, I have a Ferrari sweater. Like I said, a Michael Schumacher one. If I can fit in it, I'm not sure I will wear it. Okay, guys, have a good weekend. Bye. Practice. Practice, practice, practice. I can't say it enough. Sunday is virtual office hours. Check it out.